Hi, my name is Stella Park, and I'm in Physics 106 with Professor Della Corte. And my teaching project has been on effects of magnetic field on Mars versus Earth. So first, what is magnetic field and how is it generated? To look at the magnetic field and how it affects, we need to look at how it's formed and what kind of factors or what kind of requirements are required for a planet to generate those magnetic field. So we will take a look at Earth. Earth is, we obviously have magnetic fields going around. That's how compasses work. That's how the theories of the gravitational pull they support, and how they have been discovered. They've been supported by the theory of magnetic fields. So here's the first half of the Earth's core. So let's take a look at it. So the very edge is called the crust, and that's where we live in, and that's where most of our dirt and ocean lies in. And then the big chunk of the outer edge of the core, which is about half of the core, is called the mantle, and that's where all those minerals, all those molten, not minerals, but all those metals that exist on the Earth right here, and it's very, it's turning and it's moving around all the time. And then when we look at the inner half of the core is the outer core, which is bigger than the inner core, which is in the very center of the Earth. So the inner half of the core is what we will be mostly looking at, and that's what plays a big factor when it comes to generating magnetic fields. So we'll take a look at the outer core, and it's made out of variety of metals like iron, nickel, and it's very flowy, liquid-like. And then the core, the very center, is the inner core, and it's a solid metal of iron. And the iron gets there through the pressure of the inner core that's pushing all those iron from the liquid into its solid form. So the solid inner core is generated because the mantle, which is the first half of the core, is always overturning. It's always moving, and it overturns every 500 million years, and it's a lot of time, but because Earth is old, it is able to have enough effect. This overturning can have an effect on the Earth's situation or state as a whole. So as the mantle is overturning, it's releasing all those heat that is concentrated here because of the pressure that's being pressed on. So as the heat is released, the liquid core is starting to freeze inwards, leaving only the solid iron core left. So that was the little information about core, and we'll now move on to the actual magnetic field effect. So this is the geographical axis of the Earth, so right in the center. But here is the magnetic axis of the Earth. So it's around about 11 degrees from the geographical. And so because it has different axes, the Earth's magnetic field very, very resembles the bar magnetic field. However, when we look at the actual inside, it actually doesn't work like a bar magnetic field. In the bar magnets, it's static, which means it's very stable, all these patterns. However, in the Earth, it's actually moving around everywhere, and that's because of the core. And this picture kind of shows what it actually looks like. Those magnetic field lines look like inside the Earth. So very straight, resembles the bar magnets on the outside, but inside it's all tangled because the magnetic field is actually generated from the inner core, not inner half of the core, which is mainly the liquid section of the core. And because that liquid section is made out of different metals, it pulls the magnetic field lines in different directions, making different loops. And then it makes bigger loops and then bigger loops until it creates these big loops on the outside that we can observe. So that's how the magnetic fields are generated. So the liquid part of the core is very important. So let's take a look at Earth and Mars. So Earth, we just discussed that it has a magnetic field, and because of it, we have an atmosphere. Those magnetic fields contain the atmosphere close to the Earth. But on Mars, we don't have any magnetic field, and we'll discuss why it doesn't have it, and so therefore it doesn't have an atmosphere. The atmosphere plays a vital role in creating living things on the planet. And we'll take a look at this diagram. So here's the Earth, here's the atmosphere, and here's the sun. And these are the different radiations that Earth generates and being thrown towards the Earth and other planets. When those harmful radiations reach the Earth or the atmosphere acts like a shield against those radiations, so it makes them bounce off. So only a little bit of it can come in. So because of it, the living things are not destroyed or damaged by the sun, and we are able to keep those living things on here. When we look at Mars, however, when those radiation reach Mars, there's no atmosphere to protect it, so it keeps on absorbing those heat until the temperature goes up, and eventually it makes it impossible for the living things to live there. So those are the main differences or the effects of having or not having a magnetic field on the planet. And now we'll look at Mars core. We discussed earlier that the liquid part is vital to having magnetic field. When we look at Mars, it contains the mantle, the crust, and the solid iron core in the middle. And we observed that the solid iron core also exists in Earth, but it's not as big as the liquid core, and the liquid core is still flowing enough that it can generate magnetic fields. But when we look at Mars, there's no liquid core to get those magnetic fields moving. So it makes this diagram impossible for Mars to happen. So here's a question that a lot of the scientists, NASA, or a lot of space scientists are pondering about is because Earth is slowly freezing inwards, so slowly forming that strong solid iron core, would it eventually become like Mars? Would it lose its atmosphere, or when would it lose it? Will we not be able to have living things on the Earth at some point? And I think that's a good question to ponder about as we think about the importance of magnetic fields, as it plays a vital role in keeping the living things here. So that was my teaching project, and thank you for watching.